much, Elena. And thank you for everyone for staying after a long day for yourselves for this lecture. I'm tempted to say good morning because it's morning where I am. It's 8 a.m. in Vancouver, but I know it's a good evening for you. So it's 6 o'clock for all of you, I know. And yes, I look forward to telling you a little bit about my work and possibly taking some questions from you. I'd love to get questions. First thing, I just wanted to share my slides with you. And Elena asked if I have to do something special so I can see both my slides and people.
So far, when we see you,
you can you see my slides now?
No.
Okay, because I just shared my slides. So let's see, I will share screen. Okay.
Okay, now we can see the screen. Yeah, that's
great. Perfect.
Okay, great. Thanks.
Good?
Yeah, perfect.
Okay, so today I wanted to tell you about my thoughts about how to think about thinking. So as Elena said, thanks Elena for a great introduction. I've been studying thought for the last, not counting, but let's just say about 3 decades. And what I wanted to tell you about today is what we've learned from the neuroscience of spontaneous thought, which has been the main focus of my research in the last 20 years or so. So how to think about thinking? Well, there are at least 3 ways that we can think about thought. And this is a summary of my talk. So I'll tell you the 3 ways that I'll take you through. And what I'll suggest is that some of them are slightly more complex than others. And so the first way to think about thought is really as a point. And by that, I mean not even a one-dimensional thing. So I'll tell you what I mean by that. The second way to think about thought is as a continuum that spans a dimension of thought. And that's also a common way to think about thought. And I'll give you examples, and including of how scientists like myself until relatively recently used to try to think about thought that way. But where I'll lead you to is a third way that I've been trying to develop in the last 10 years or so, which helps us think about thought at least as a 2-dimensional space. So that way of thinking about thought has been really inspired by really staring at the brain. So what does the brain do and how does it organize thought? And I'll tell you what we've learned about that. So first of all, how do you think about thought as a point, as a thing? So here's an example that I'll start with. This example is very old. It comes from a book published in 1925, but it captures a lot of the thinking that went on about thought throughout the 20th centuries. So let's go over it. This is a book published by Donald Laird, who was an eminent psychologist in the early 20th century. And his book was called Increasing Personal Efficiency. It's just an example. There's many books that have been published similarly flavored, but this one was popular. It was republished several times. And the one example that I'll give you from that book is some discussion that Professor Laird introduced of effective thought. So his chapter number 8, called Effective Thought, presented an example of what it is like to think. And in that example, he introduced 2 individuals and examples of their own thoughts processes. So let's see how he described it. These are excerpts from the book that I've taken almost verbatim. So the first individual that he looked at was the executive. He called it the executive. So this is the executive manager of a company. And what he described was an example of his here's what he's doing. We're observing him, the executive of a company, and of course he's not to be interrupted, but let's observe him for a few moments in his office. For more than an hour, he has been alone and quiet. He says nothing and is apparently motionless. But is he doing nothing? He was probably doing the hardest work of the week. He was engaged in active thought. So this is the thought that was identified in this example. Now, by contrast, the other individual who we're going to observe here is referred to as the maiden. And she has been reading for a while, but suddenly drops the book in her lap and stares to the distance. The spring flowers and the budding trees are not sensed by the maiden. Her faraway gaze focuses in her mind on scenes vastly different from what's in front of her eyes, because she sees gallant knights and fair ladies in her mind, and she even sees one of the ladies as herself in her mind. She's enjoying an indulgence of what Donald Laird refers to as passive thinking, for such daydreaming and the weaving of fantasies are what she's doing. So this example is interesting because obviously it's a caricature of how we think about thinking. And in fact, I want to argue is that this is actually a way of thinking about thought as a point. And let's summarize how, according to Donald Laird, we can see these two types of thinking that actually he's outlining, but he's also passing a value judgment on these two types of thinking. So first, the maiden's type of thinking, this passive thinking that he calls it. He describes it later on in the chapter on effective thought as unproductive. This kind of passive thinking, reveries and daydreams and wishful thinking is unproductive. It's self-indulgent. It gratifies our wishes in our minds, in reverie, rather than in reality. That's why it's unproductive. It's also found in nighttime dreams. He speculates and he says, yes, an extreme version of this kind of passive thinking is what generates our nighttime dreams. And he claims that it predominates in neurotic and hysterical patients. So these were terms for mental health disorders about 100 years ago, which is what he used. So his statement is that this is what constitutes mental health disorder at the time. His claim is also passive thinking dissipates our mental energies in fruitless reveries. So again, that's useless to engage in that kind of thinking. And finally, he concludes that it presents a handicap to efficiency. So in his chapter on effective thought, obviously, he advises people to not engage in this kind of passive thinking. The point is to engage in the other kind of thinking, which he calls active thinking, which is, and he cites someone else from that time, thinking that works. It works because it helps us achieve our wishes in real life rather than in our minds in this imaginary, useless way of achieving them. He also then went on to make a claim, which actually resonates for a lot of the thinking that's happened throughout the 20th century, is that this kind of active thinking, it is what separates man from brute. He says it has been one of the strongest forces in bringing man to his present position of supremacy in the scale of animal life. And active thinking is the kind of thinking that man should continue to cultivate. So this is his main point in the chapter on efficiency in thought. In fact, he ends with giving a goal to the reader, which is to ask the reader should ask themselves this personal question to assess their own progress in improving their efficiency of thought, asking their question of, do I spend more time in active thought than I do in passive thought? In other words, the point here is to use active thinking. So this is the whole frame of the book. And he acknowledges that passive thinking occurs, but again, the idea is to avoid passive thinking and to think in active ways. So the reason why I see that as a way of thinking about a thought as a point is because it picks, first of all, it looks at actually a dimension of thought from active to passive, but then it really discards everything along that dimension than the extreme that, according to him, is very active. And you might think, okay, well, that's from the 1925. Sure, the book was popular, it was republished several times, but surely we've moved forward from that kind of thinking. And we have, but only very recently, because if you look at a lot of the literature and discussions of thought throughout the 20th century, including in neuroscientific circles, you see that that standard of this, what is here referred to as active thinking, but what we ended up referring later on as executive functions, not unrelated to the executive who was having that active quote unquote thought, is what dominated research in the 20th centuries. And I can speak most confidently about my own field, neuroscience or cognitive neuroscience, which was very strongly focused on studying this point, what Laird called active thinking, but what we called throughout the 20th centuries executive thinking. And not many of the arguments that Laird made, including the fact that so-called passive thinking is bad for you, it's the basis of mental pathology or disorder, and it's the height of evolution in humans, was in fact being made throughout the 20th centuries and into the 21st century. I'm showing you examples here of a very popular book on the prefrontal cortex. The prefrontal cortex became the synonym for executive function in terms of neuroscience because it was studied extensively and it was linked very strongly to this kind of thinking that we ended up calling executive. This is a picture of me from many years ago when I defended my master's dissertation in Bulgaria. And so, as you know, I was an undergraduate student and a master's student in Bulgaria in New Bulgarian University. And I have extremely fond memories, which are being somewhat reactivated now by this school, because it's great to be back and teach at this school after so many years. One of the things that I also remember is these gatherings that Boycho Kokinov, who was my undergraduate advisor and my master's thesis supervisor, organized. And with Boycho, I was able to do some of the first research. Boycho here is on the left, bottom left, and Ivo Vailev, who is about to present a lecture to you on Thursday, is second on the left as well. Ivo Vlaev, and together with Boycho, some of the first research I was engaged in was on thought. And one of the things that we investigated at the time was something that Boycho was very interested in, and I became very interested in as well. And it had to do with how contextual effects influence people's thinking. So we would give people problems to solve. So we were asking them to engage in this active kind of thought that Laird identified 100 years ago. And then we would be interested in how their thinking was interested by factors outside of their thinking. So at the time, without knowing, we were actually engaged in a somewhat more complex form of research than what was prevalent throughout most of the world's approach to thought, or I should say most of the Western approach of thought. And this is something that I was surprised to find out, because after I graduated from New Bulgarian University, I was able to go to California to do my PhD. And when I arrived at Stanford, I was hoping I would be able to continue studying this at least one-dimensional thought, where we looked at more passive influences or more active influences on thought. But instead, I found a field of neuroscience as a PhD student, which was really focused on these executive functions. So this is an example of my research that the first fMRI study that I ended up doing in the late 90s and published it in 2001 as a graduate student. And what I had to do if I were to graduate with a PhD was study executive functions and the prefrontal cortex, because if anyone was interested in studying thought, and not many people were interested in studying thought, I was one of the few researchers. Most people were interested in studying memory, perception, and really that's it. But if you were interested in studying thought, you had to focus on this kind of very active type of thinking, what was considered at the time called executive functions. So what you see here is an example of a problem or a series of problems that we ended up constructing. Those are similar to what are known as the Raven's progressive matrices. And really, they're one of the prototypical example of how we study these kind of executive functions, because we give people these series of objects that change from left to right and from top to bottom, and they have to guess, they have to infer what changes from left to right and what changes from top to bottom, and what should be the missing answer based on their inference. And as they infer things in their mind and think about these inferences, how they come together, we are observing what happens in the brain in terms of executive functions. And what happened in the course of my research is that at the time we were all about the prefrontal cortex in terms of what we were interested in studying. And for the first time, what I found, and I was very proud of my finding at the time, was that there was this part of the prefrontal cortex which became activated when people were solving our hardest problems, but not so much when they were solving simpler problems like these, which don't require as much executive thinking as this more complex problem did. And so this activation is activation across 12 subjects. And when I saw this part of the brain light up, I thought, wow, this is like the apex of the human brain, the prefrontal cortex, which is evolutionarily so new. And I'm seeing activation in it across these 12 subjects in this really highly executively complex task. Now, the hitch to it was that about a year later or two, I ran another study where I looked at a condition which was used as a baseline condition at the time, so a condition of no interest. And we used to call that condition rest. So I was suspecting that actually this part of the brain doesn't become activated during executive thinking if we have a condition, a baseline condition that's a resting condition. So I wanted to find out what are good baseline tasks that help us activate the RLPFC, or the rostrolateral prefrontal cortex, better. And what I found was something completely unexpected for me, and in fact unpublishable for a couple of years because it was so unthinkable for the research at the time. What I found was, so basically in that study, what I did was I gave people two different baseline tasks in order to compare what's the pattern of activation more so during one than the other. And the two baseline tasks that I gave them were what I called arrows. So they would see an arrow on the screen every 2 seconds. This was the simplest possible task that I could think of that was not passive, but would require people to look at the screen and do something that does not involve much thinking. So if the arrow pointed to the right, they had to press a right button. And if the arrow pointed to the left, they had to press a left button. So it was a very automatic task that still required them to press buttons and look at the screen, but required as little thinking as possible for a task. And then I compared that arrows task to 16 seconds of rest when people were doing nothing. So you have no task, you're not pressing any buttons, you're just lying in the scanner, and you could look at the top of the scanner just like this maiden was looking out at the scene, but you're not required to do anything with that. And the biggest surprise to me, I was so shocked by that I printed out the activation results across 20 subjects and printed it on my office door, because there had to be something going on there, was that it was the task when people were doing nothing, when they were being completely passive, according to this definition of passivity, that was activated the same rostrolateral prefrontal cortex, but it looked to be even more so than the activation that I was able to observe when people were doing these highly abstract executive tasks. So something was not quite right about the way I had been thinking about these executive functions in the prefrontal cortex. And I'd come to realize later on, it wasn't just me, it was how most neuroscientists and many scientists, including the psychologists who had been writing books like Donald Laird, had been thinking about it. Now, this was in the onset of the 21st century, so early 2000s. And around that time, it was a bit of an awakening going on in cognitive neuroscience, because we were just waking up to the idea that something was up with rest, i.e. that rest was not exactly that passive, do nothing, nothing going on in the brain kind of condition. In fact, a lot of the thinking about rest up until that time had been that it's a good baseline because nothing much happens during rest in the brain. And if anything happens, it's so inconsistent across people that it'll average out and it'll give you a good baseline for the brain. I'd heard that explanation as why we should use rest. But around that same time, the early 2000s, people started talking about a set of brain regions that in fact were very systematically activated during rest. So this is what ended up becoming as the default mode network, which I'll tell you a little bit today. But at the time, for a while, we didn't have a name until Mark Rako ended up calling it the default mode of brain function. But actually, for at least 10 years before that paper and that label emerged, a number of papers had been published. This data set is actually a data set that had been published by Robert Schumann in 1997 that showed that, contrary to that belief that what happens during rest is so inconsistent in the brain that it will average out across subjects, when you average the cross subjects, in fact, we saw you would see a very consistent set of activations in the brain. So this is what became known as the default mode, and later on is the default network. Later on, people started doing functional connectivity, which I'll show you some examples of. And that's how the default network emerged. Now, the point here is that during rest, there's these very consistent activations. They're actually very strong. Some of them extend into the ROPFC, which is what I was seeing during rest compared to my very simple AROS task. But if you, these data set here are comparisons between rest and a little more complex tasks. So this is comparisons, I think, like hundreds of subjects and maybe dozens of tasks where people were doing nothing compared to doing reading or verb generation. So during rest, the brain was actually highly active, and it was active in this very consistent pattern where we would see activations in the midline parts of the brain. So this is the medial prefrontal cortex, as well as a number of other regions that I'll tell you about as we go along. So the point here is that as we were starting to learn as neuroscientists around the year 2000, there was nothing passive about the brain when the body is still lying in the scanner doing quote unquote nothing according to the experimenter. Where they're not pressing buttons, they're not looking at any stimuli, but the brain is really active and in a very consistent way. And in that sense, I think the irony here is in some sense that in the year 2000, we were rediscovering something that of course had been known to poets and philosophers for a very long time. Right around that time, I randomly picked a book by Seneca called Letters from a Stoic in a bookstore. And as I was reading, I came across something that we were just discovering in neuroscience. Seneca wrote, "The fact that the body is lying down is no reason for supposing that the mind is at peace. Rest is sometimes far from restful." Lo and behold, that is what exactly we were seeing in the brain. Rest is sometimes far from restful, indeed. So this is one of the ways in which, at least neuroscientists, but I think the field of cognitive science was in a large way consistent with that idea of what is active, what is passive, and what is worthwhile thinking, let alone what's worthwhile studying, started being pushed towards thinking about a continuum of thought. And as I said, active and passive is a continuum, but because it was so heavily weighed as a continuum towards active thinking as what should be studied and what was studied, it was hard for us to think of other ways in which thought might be spanned on a continuum. But around the year 2000, I think there was more scientific thinking being done towards thought in terms of how it could be researched as a continuum, not just in terms of this dimension, which I think is ultimately incorrect, active versus passive, but also in terms of the various other dimensions that could span different continuums. So I'll tell you about the continuum that ended up being largely definitive of a lot of the research in thought at the time that I was part of. And in some sense that started a new era in the research. And one way to think of it is to think of it as the era of mind wandering, because in the early 2000s, or more precisely around 2006, we started using a word to designate what Donald Laird used to call passive thinking. And there had been many words before that had been used, things like task-unrelated thought, stimulus-unrelated thought, daydreaming was also being used. But in research, this word mind wandering became a term that started taking off in terms of the number of research that would be done. So what you see here is just a plot of the number of papers that were published up until 2006 with the word mind wandering in it. And then you can see how the number of papers started going up. And by 10 years later, from 2006, there were more than 100 papers in science, not just in neuroscience, actually predominantly psychology to begin with, but partly it infiltrated research into neuroimaging. And I'm partly to blame for that as well, because we did some of the studies in neuroscience. They used mind wandering to study mind wandering. So what we were doing with that term, it was just another term to try to help us study this other side of the continuum. Okay, if you have this executive function, but you also have this other kind of thinking, which seems to happen during rest when the body is inactive, what is it? And so this was actually Jonathan Smallwood and Jonathan Schooler, who were my office neighbors at UBC at the time. This coincided with my taking a job at UBC. Who published a paper using mind wandering, and then we started studying mind wandering. Again, it was just a term for trying to characterize that kind of thinking that is not executive. Right? Now, at first, mind wandering, Jonathan Smallwood and Jonathan Schooler defined it, and it's still predominantly defined that way, the term mind wandering. They defined it in terms of the static momentary contents of thought. What am I thinking about currently? And if I was thinking about something that was not related to my current task, so that's task-unrelated thought, or if I was thinking about something that's not related to what's in front of me currently perceptually, so that's a term that is known as perceptually decoupled. So it's decoupled from the perceptual environment, or more harking back to behaviorist terms, it was sometimes referred to as stimulus-independent thought. Then Smallwood and Schooler would argue that's mind wandering, and that is how mind wandering became defined. Now, what you see here is that it's task-unrelated and perceptually decoupled. Those are actually things that Donald Laird identified back in that thinking that the maiden was engaged in, because if you remember, he described how she didn't see the roses and the smell. She couldn't smell the beautiful rose smell in front of her or see the landscape because she was seeing something in her mind. So this is really what we're meaning by perceptually decoupled here. And she wasn't reading even anymore. She had been reading up until recently, but now she put the book in her lap. So you could argue that she wasn't even thinking in a task-related manner, whereas the executive was thinking in a task-related manner because he was thinking about his job and how to improve his product or something. So for better or worse, the way we define mind wandering to begin with, a definition that I always had misgivings about, but I ended up adopting to begin with, is in those terms, task-unrelated and or perceptually decoupled or stimulus-independent thought. And based on that, the definition that I adopted in collaboration with Jonathan Smallwood and Jonathan Schooler, we ended up doing an fMRI study, which was one of the first fMRI studies to probe people, to ask them questions in the scanner about what kind of thinking they're engaged in, and then look at the brain to see what specifically becomes active, not just during rest when we actually don't know what they're thinking about, but we just see that something's going on in the brain. We wanted to know what happens in the brain just before they give us information about the kind of thinking that's going on in their mind. So I'll quickly tell you about the procedure that we use here to give you an example of a technique called experience sampling, which is something that I've now started using very heavily in my research. So experience sampling is a 21st century term, you could argue, which is similar to another term or another procedure, in fact, almost identical, called thought probes. So there was more, the term that was used in the 20th century was thought probing. But both of them involve giving someone either a task or giving them nothing, like rest. And then periodically you stop them and show them something like this on the screen, which we call a thought probe. Or this could be an experience sampling probe, if you prefer that newer terminology. So basically, you ask them a question. And in our case, the question was, where was your attention focused just before the probe? And again, in this particular study, we actually gave them a task. Nowadays, in most of our research, we would give them no task. We would just let them rest. But at the time, rest was still not quite a legitimate thing to use in your procedure. It was still more considered of a baseline. So we gave them this task. The other reason why we gave them a task was that we wanted to see examples of mind wandering. In this definition of mind wandering, the mind going off task, right? Task and related thought. When we catch this task and related thought based on their task performance, as well as catch task and related thought based on their subjective reports through experience sampling. We wanted that comparison. So the task we gave them is this thing here called it's a task called the sustained attention to response task, or the SART, which you don't have to remember or anything. I won't mention it again, but I wanted to give an example of the typical task that we would give them. A typical task that people tend to wander away from a lot because it's really boring. Okay, so the task goes like that. You see a number on the screen every 2 seconds. So these are the seconds on the screen, the 26 second, the 28 second, and so forth. Every 2 seconds, you see a single digit, a number that's a single digit on the screen. And what you have to do is you press a button every time you see any digit, except if you see 3, the target is the digit 3. If you see the number 3, you're supposed to not press the button. So you're supposed to withhold the button. And it's really boring because there's not much to do other than just keep pressing a button every 2 seconds. And the catch is that if you see a 3, because you've been pressing the button so frequently, so repeatedly, 3 shows up, you actually, it's kind of hard to not press. And sometimes people press by mistake, just by inertia, because they've been pressing it again and again and again. So the theory behind this task is that if you press for the 3, then you're committing an error on the task, because you might have been mind wandering and not paying attention to the task, and you didn't stop yourself fast enough, and your body kind of was faster than your ability to stop yourself to pressing the button. But if you withhold or not press the button to the number 3 correctly, then the idea is that you are probably more likely to have paid attention to the task, and therefore being fast at stopping yourself from executing this habitual prepotent response of pressing that button. So this was actually what we wanted to see in terms of the behavioral signature of task and related thought when we compared. Oh, and the other thing we did in the scanner was, the way we did the analysis, we didn't look at what happens during the button press or during that probe. So the probe was, where was your attention focused just before the probe? Were you paying attention to the task, or were you going off, mind wandering off task? And people could respond actually on a scale of 1 to 6. That doesn't matter, because then we ended up binarizing all the responses. But what you see here as results and as activations in the brain is not what happens during this probe, and not what happens during the button presses, but what happens in the brain before that probe. So the logic here is that, yes, when they see the probe and we're getting that experience sampling, they tell us what was going on in their mind, but we phrase the question specifically to ask them, what was happening in your mind just before the probe? So then when we did the analysis, we actually looked at the brain just before the probe. And one advantage of doing that is that we only probed people once every 70 seconds. So that's more than a minute. And the idea is that they kind of get into a mental state that doesn't necessarily anticipate the next probe. So they might be thinking about the task, or they might be thinking about their dinner or their plans for the next day, but they're not wondering, I wonder when the next probe would come. So that's why we gave them probes very infrequently in order not to be disruptive of their natural mental processes. So what we saw was partly unsurprising and partly actually surprising. The unsurprising part was that we saw the default network activated. So the default network is marked with these blue arrows. Actually, sorry, it's the other way around. The green arrows are marking the default network. The blue arrows, so that was unsurprising because we knew that the default network is activating during rest, and people had been postulating that this is related to mind wandering. And there was one other fMRI study that has shown that people who tend to mind wander more activate a default network more during rest. But the part that we were not as prepared or expecting to see was the blue arrows here, which point to actually executive regions of the brain. So what we saw activated before reports when people said they were off task versus reports when they were said they were on task was both default network regions. So medial prefrontal cortex here and the posterior cingulate cortex, as well as this is more medial prefrontal cortex here as well. This region actually is known as the dorsal anterior cingulate cortex and is known to be one of the executive regions of the brain, as well as these regions here are the dorsolateral prefrontal cortex on both sides of the brain. They are the prototypical executive network region, along with the dorsal ACC. So what was going on in people's brains just before they told us they were not thinking about the task or they were doing task and related thought was actually really complex, really active. And it was not even just the default network active, but even some of these networks, part of the brains that we have been thinking as hard work, active executive thinking, were also being activated before people were going off task. So again, I think this was one of the interesting ways in which my own thinking about thoughts, and I think most of the research that I'd been reading started not quite making sense. And it was obviously in need of revision, because even that dimension that we were thinking about now, okay, executive versus not executive, directed, goal-directed versus undirected, started slightly not working in terms of explaining these regions of activation. Because if it was executive versus not executive and people were not thinking about the task, why were they activating their executive parts of the brain? So all kinds of explanations we started trying to draw. For example, people had been saying for a while that actually even that quote unquote passive thinking was often goal directed, because when people weren't paying attention to the task that we were giving, they could have still been thinking hard things about their lives. Their lives are pretty difficult, sometimes much more difficult about our tasks. So maybe what was going on was actually a mixture of executive and default, which is actually what we were seeing. Now, that was still dominated by this idea that there's some dimension of thought, and we must identify the most important way in which thought ranges from this more executive to maybe less executive, or something else, more task-oriented to less task-oriented. So this is an example of a paper that I published shortly after, which was trying to account for these findings that we had. So, for example, the dimension here that we were discussing was, okay, well, if you distinguish mind wandering from goal-directed, what changes along it? And not just cognitively, but also the brain changes we were seeing. And one thing that I've always been interested in is creative thinking, which to me always combines some interesting features of goal-directed thought and mind wandering. And there was some neuroscience of creative thinking. So I would try to position it between mind wandering and goal-directed thinking on this continuum. And another thing that I've always been interested in is actually nighttime dreaming as well, of which there's also a little bit of research. It's hard to do that research, but I would also try to position on this continuum. And it sort of seemed to be making sense that there's this continuum. And then we also had these neuroimaging findings of what changes. So, for example, one of the papers that came out, this was actually a book chapter that we published at the time, try to say, okay, well, we have the lateral prefrontal cortex, which is, of course, the epitome of human evolution and executive functions. And okay, what happens during it? We also have the default network. You actually see, this is a good way of displaying some of the most central regions that are thought to be part of the default network: medial prefrontal cortex, the posterior cingulate cortex, the inferior parietal lobule, another part of the brain on the side of the brain that's part of the default network. What you see here is that dorsal anterior cingulate cortex that I was showing you is not part here, right? Because that was also actually active during task and related thought. And then we have these mediotemporal lobes that are part of the default network, but also they have their own history of really rich research, known to be involved in something called long-term memory and associative memory. And we also know that if they're damaged, people can have troubles forming new memories. But these regions seem to be active during rest as well, along with the default network. And so here is just an attempt that I was trying to do, trying to create of how the continuum from goal-directed to creative to mind-wandering may be represented in terms of the contributions of different parts of the brain, like the lateral prefrontal cortex, memory regions, default network. And you can see it's a little messy, and we're trying to create not a linear, but maybe a gradual, some kind of a somewhat different function of how the different regions are involved. But there was still a major handicap in here, because I, in my own mind, thinking about thinking, I was still trying to arrange these different kinds of thought along a continuum. That continuum, I was open to it being anything, but it was still a continuum. Like I was open to it being defined by different brain regions or brain networks in different ways. So this was the thinking that was going on in neuroimaging in terms of the different types of thought. In terms of psychology, something started happening when it comes to mind wandering, which was interesting. And it also defined its own continuum, but it kind of went back almost to a point way of thinking, the Donald Lair way of thinking about thought, where mind wandering became this bad thing to do. So just like Donald Lair had been saying, this passive thinking is something you should avoid, it's unproductive, it leads to problematic mental health conditions. Somehow this kind of thinking, I thought, I was surprised at the time because it didn't match my own experience of mind wandering. But one of the most influential papers to this day was published in Science, one of the most influential journal, claiming that a wandering mind is an unhappy mind. And so at the time, actually, I was giving birth to my first child, and I wasn't really tuned into all the research. So when this came out, I kind of missed it, and I only saw it 6 months later, once my kid was past the emergency stage of having to attend to them 22 hours or 24 hours a day. But when we looked at it, and together with my students, it took another 6 months to do a little bit of analysis of this paper and to do some more research into it. What we saw was something surprising given the claim of the paper. So even though the claim was that a wandering mind is an unhappy mind, the data actually seemed to be not indicating that extreme state of unhappiness that the title suggested. So this is very complicated. I'm not going to talk to all of it, but One of the things we noticed was that they separated mind-wandering episodes into unpleasant, neutral, and pleasant mind-wandering. And by the way, in this paper, they defined mind-wandering in the same way that I told you about in terms of static content. They just asked people, are you thinking about what you're currently doing or something that you're not currently doing? So it's, again, what are you thinking about? And is it related to your current activity, which can be thought of kind of as a task? So is task unrelated or unrelated to the current things that you're doing? So what you see here, the size of the circle here indicates also the number of responses. So it's hard to see or to quantify it, but we were able to do it based on some of the reports, the numerical reports in the paper. We were able to estimate what was actually the average state of the mind emotionally. Was it unhappy, or was it neutral, or was it pleasant, actually, if you look at these three balls, right? Or these three circles here. When people are not mind wandering, they were, so this is a scale along which people reported their state of happiness or unhappiness. It ranged from 0 to 100, where 0 was unhappy and 100 was very happy. So what we were able to see, by the way, their conclusion was very strong, although as you see, actually didn't quite match what the data was. Because in conclusion, this paper argued that a human mind is a wandering mind, and a wandering mind is an unhappy mind. And they inferred the ability to think about what is not happening is a cognitive achievement that comes at an emotional cost. So this is actually very similar to the arguments made in 1925 by Donald Lair, although he called this kind of thinking passive. And here we're calling it mind wandering. But the data, if you look at the data of that paper, which we were able to do based on some of the numerical reports, is what we see then is that on that scale of how are you feeling when you're mind wandering or going off task, is it very bad, 0, or is it very good, 100? This was their scale. So the midpoint of that scale that they use is 50. The average that people reported is actually 58. Now, of course, sometimes people were here, maybe sometimes they were even here, but sometimes they were here, and that's why the average ends up being 58, right? So we were very surprised by the title of the paper, given that average. But the argument the authors make, and they've made it afterwards as well, is that even though it's just to the positive side of the midpoint, when people are not mind wandering, they're actually slightly higher than this point. And that is why they feel that this is an unhappy state, because you could be actually happier on the average if you were paying attention to what you're currently doing. Now, that still doesn't quite, for my experience of mind wandering, make sense with respect to mind wandering, because most of the time when I mind wander, actually, I feel better than if I'm concentrated on a very boring task. If it's a great task that I love, then I might feel happier, but that's not my experience with most tasks, is that they don't actually make me feel great. Now, the other thing that we did as the years unfolded after that publication of that original paper, the Killingsworth and Gilbert paper was published in 2010 in Science. And then people started doing that research, stopping people with thought probes and asking them about their emotions, and then measuring whether they're feeling very negative or very positive when they're wandering away, task and related thought. So you'll see that these are a lot of studies that we've plotted here that have done something similar. Now, they've all used different scales, but the scales tend to range from -3 to +3, from 1 to 5. It doesn't matter. We've actually lined up the scales here, so the midpoint lines up. And what you see here is the averages of emotional state or affect during task and related thought. And what you also see is that on the average, now these are averages, that also means there is a variability around them. And I'll speak to that a little bit in the next couple of slides. But the averages are actually very consistently kind of very similar to the midpoint of these scale between unhappiness and happiness. So you could argue that they're neutral. If you're an optimist about mind wandering, you might also start arguing, well, hold on, they're actually consistently to the right of these midpoints. So is it really unhappy if consistently we're on the positive side of things? But if you're a pessimist, you might say, yeah, but it could be even better. So that's kind of unhappy because you could be happier than that. Whatever it is, I think one of the biggest story here is that a wandering mind is not necessarily an unhappy mind. It could be, but it could also be super happy mind. And on the average, it seems to be kind of neutral, maybe mildly positive on the average. Now, these averages, though, as I'll say, hide a real big variability. But this kind of tendency that I think to this day persists in science to kind of equate mind wandering with bad things in the mind, with like horrible things going wrong in the mind, persisted. So this is not a paper that got published, also in Science, very influential. Just a few years later, I think it was 2013. I can't see actually the top of my slides, just so you know, because the Zoom images are there. But this paper was titled "Just Think the Challenges of the Disengaged Mind." And what the paper, this was also a very surprising paper. When it came out, it made a big splash in the newspapers in the West. Because the newspapers reported on this paper with titles like, "People would rather shock themselves with electricity than think." And this is in fact one of the claims that the paper made in the title. So these authors reported as many as 11 studies where they found that participants typically did not enjoy spending 6 to 15 minutes in a room by themselves with nothing to do but think. And that they enjoyed mundane external activities, tasks, much more, and that many prefer to administer electric shocks to themselves instead of being left alone with their thoughts. So this is what the media newspapers latched on. So the conclusion was that most people seem to prefer to be doing something rather than nothing, even if that something is negative. Now, again, not just myself, but a number of researchers that I work with who had been studying mind wandering, we were all kind of surprised by that, because that's not what we had been finding, and that's not what we had been seeing in the literature. So in this case, actually, very helpfully, the authors of the previous paper published their entire data set. So this was in a move towards open science. And so what we were able to do is not just average the numerical data that they presented, but actually go back to their data set and analyze it to see to what extent these claims in the title were supported. So we ended up writing a commentary on that paper on the basis of these somewhat different analysis of their own data set, where we were very appreciative of the rich data set that they collected and provided, but actually we weren't able to see a lot of support for the claims that were being made. So what I'll show you is one of the analysis that we were able to do based on their own data. The publication didn't present that kind of analysis. So when people were asked, people were left with their own thoughts here from 5 to 12 minutes in a room by themselves and so forth. So if you look at how people reported their experience of being left alone with their thoughts, what you see is actually very similar to what I was showing you like in a couple of slides back across these 10 or so studies. Again, the average is exactly in the middle point of the scale. If the scale here was from 1 not at all enjoyable to 9 extremely enjoyable, which is the scale that was used in this paper in Science that I showed you, what their own data showed was that there's actually a huge distribution of how people experienced that being left alone with their thoughts. And yeah, the average is kind of midway. It's somewhat enjoyable. It's not extremely enjoyable. It's not like being left to watch a movie on Netflix. But it's not unenjoyable either. And then the other big story that you see here, also the similar thing with the shocks. Yes, a few people, 5%, administered a lot of electric shock. Like these were not huge electric shock. This was a tingling sensation that they could deliver to their hand during these minutes of being left alone with their thoughts. The majority of people actually did not administer any of these tingling sensations because they actually reported that they were happy enough to be left alone with their thoughts. A minority of people did get a little bit bored with their thoughts. And also there was this other thing that they had the option of doing other than thinking to themselves in front of the computer. They could also press a button on the computer and that delivered a tingling sensation to their arm. And so some of them tried it, delivered it once, some of them tried it twice. But this idea that the people in general would rather shock themselves than think doesn't really pan out here. There's just a lot of variability in how people experience their own thoughts. And in fact, this is, I think, to me, the big story about how we experience our own thoughts. There's a huge variability, not just across people. And by the way, the variability across people would explain why some scientists tend to make conclusions that are the opposite of other scientists. Maybe scientists themselves experience our own thoughts differently, and therefore are driven to interpret our own data sets, especially when the data sets have such variability in themselves differently. So how we experience our thinking differs not only across people, but I think it also differs a lot within individuals, from activity to activity or from thought to thought, and from different periods of our lives to other periods of our lives. We may experience our thoughts very differently. Sometimes we may experience them as depressing and anxiety provoking or traumatic. And at other times we may experience them as the opposite of that, as enjoyable, happiness generating and so forth. So in some sense, I think I'm telling you all this because partly it's a good window into some of the pitfalls that scientists ourselves engage when we study thought, because a lot of the thinking about thought is inspired by our own experience with our own thoughts and how we interpret our own data, but also in part because it really underscores the challenges of trying to think of thought in this continuum, of trying to force it into a one-dimensional stage of, in this case, not enjoyable or extremely enjoyable, or task-related and task-unrelated. So when I was looking through this data set, I was starting to think something's really wrong. This was basically something like about 15 years ago, maybe even 10 years ago. So the early 2010s. I was starting to feel like our research in mind wandering and daydreaming started to seem a little bit like the book by Robert Louis Stevenson, which you may have heard about, Dr. Jekyll and Mr. Hyde, in terms of people's attitudes towards mind wandering and daydreaming started to feel as though we were vilifying it, but also it was something that was presenting to us as potentially good. It made us feel good, daydreaming, and then suddenly it would come and do damage to us. This was kind of the black and white, or some kind of a almost conspiratorial thinking that daydreaming and mind wandering was doing. And I was, at the time for myself, I was growing really unsettled about how much of a science we were able to do with this kind of view of mind wandering and daydreaming. And what really drove home to me, underscored in my own mind, the shortcomings of the scientific thinking in that area at the time was a letter and a phone call that I received from a lawyer in Hawaii, who contacted me as someone who had been doing research on mind wandering and asked for my advice for a legal case that he was helping his client with. So I'll tell you about this case in order to give you an idea of how different the world outside of science was in some ways, and how much what we were doing in science was spilling outside into legal cases in ways that really started to concern me. So this is the case of Jennifer Smith. Jennifer Smith is not the real name of this person, but it's the client of the lawyer who contacted me. And so here's what the lawyer told me when he contacted me. Here was the case. So Jennifer Smith is a 60-year-old widowed Maui shop owner. He wrote to me in this letter and then told me more on the phone. What happened to Jennifer Smith was that one day on the way home from work, she drove into a number of cars, stopped at a red light. So she was approaching the red light, and instead of stopping at a red light, she drove into the cars that was stopped right in front of her. At least one person in the cars in front of her was severely injured. So this was a car accident that had really negative causes to people in front of her. And because of that injury, a criminal case charging Jennifer with gross negligent injury was filed. So gross negligent injury is the legal term for if you cause bodily damage to someone and you were negligent in some case. In this case, the negligence that she was charged with was in her driving. She wasn't driving appropriately, so she was negligent in her driving. The state of Hawaii, in this case, filed this case against Jennifer, and she was on trial for that. So here's what her lawyer said. She had not been driving. She was not texting or fussing with anything while in the car. And it was not her intention to have a collision. So she didn't actually intend to cause that collision. And so the lawyer presented in his letter the case that somehow her mind wandered. And he also said it was the 1-year anniversary of her husband's death, and she was in treatment for chronic but mild depression. So these were the circumstances that he laid out. And in his letter, he posed this question to me as a scientist. The lawyer asked me, and he said, I have been at a loss finding anyone to answer the question whether Jennifer's mental lapse was voluntary or something the reasonable person can and should control. He went on to say, all of us space out from time to time, short of falling asleep, even while driving. It's true, we do space out while driving. And then he said the voluntariness of this state of spacing out and whether Jennifer has some propensity that may exacerbate or aggravate such a state are the issues we are facing. So the lawyer is doing his job. He's trying to defend this person, but he's also employing a psychological analysis of Jennifer's mental state while driving. And so he's relying, and he found my name because he saw my website as stating that I study fMRI, I use fMRI to study mind wandering. So he figured out that I should be able to answer these questions as an expert on mind wandering. And speaking to him on the phone, I realized that, you know, what we had been doing was not only not helping people out, it potentially could be misused to put someone in jail, right? Because what I saw in his argument was actually an inaccurate interpretation of all the science. And in fact, to his credit, it was a very feasible interpretation of all the science that somehow her mind wandered. But to me, what I focused on was what I highlight in yellow here. What my mind as a scientist focused on was not the possibility that her mind wandered. I don't know if her mind wandered or not, but the fact that it was the 1-year anniversary of her husband's death and she was in treatment for chronic but mild depression. So what I knew by then was something to do with traumatic experience, which was that when people who have gone through something traumatic go through the anniversary of the trauma, they often re-experience that trauma. And what I started thinking when he told me this story was that it doesn't matter whether her mind wandered or not. What's much more important for understanding this person's mental state here is that she very likely was going through a re-experiencing of the trauma of her husband's death on that one day when she was driving. That seems a much bigger definitive influence on her mind than whether she mind wandered or not. because in this case, what I started thinking about was how little we were able to as scientists, how little we were able to differentiate or distinguish between mind wandering and something like an intrusive thought, which is likely what would happen if someone is re-experiencing their trauma. So the re-experiencing of trauma, sometimes people have them in the form of traumatic flashbacks, are a very strong form of intrusive thought that can basically take over the mind in terms of attentional state. And this is the kind of thing that's actually very different from mind wandering, because even though up until then we had been defining mind wandering as task unrelated thought, task unrelated thought in the form of mind wandering is in general possible to disengage from. You go task unrelated. Let's say I've given you the start task that I told you about, where you have to press a button every 2 seconds, and then you see the number 3, and you suddenly press and you realize, oh no, I made an error, I pressed where I shouldn't, and you redirect your attention back. But in this case, this wasn't a regular task unrelated thought she was engaged in. She was engaged in a thought that made her not be able to stop the car. So it was so overpowering, the mental processes in her thought, that she was not able to stop even when the car was approaching really close to the car in front of her. So what I realized out of this is that we really need to do in science something different than what we had been doing, because based on what we were doing, first of all, it was very difficult to relate to real world cases. But when people were starting to relate it, it could potentially really do injustice to people's mental states. At the time I began working with one of the people who became a close collaborator, Zach Irving. He was a postdoc in philosophy, so he was a philosopher by training. And together we started thinking, he had also been interested in mind wandering from a philosophical perspective. And I credit him with a shift in my own thinking that was very relevant to this case that I told you with Jennifer's experience and her legal defense. Zach Irving came as a philosopher with a different intuition from my own intuition as a psychologist, having been into that field for a while. Zach argued with me, and after months of arguing, he convinced me that rumination and intrusive thought are actually not spontaneous. And because of that, they are not mind wandering either. And the reason why they're not spontaneous and they're not mind wandering is because, and they're not wandering, is because if you look at even the word wandering, wandering in English is a verb, a wander, to wander, is a verb that describes a certain kind of motion, a movement in space. And that movement is something like moving about that space without fixed course or aim, but it's a moving about. It's not so much about where you are in space, but it's about how you are moving around that space. So if you look at the term mind wandering, it's actually an analogy or a metaphor, if you like, with that wandering in space that we do. And so the metaphor is what we do in the mind when we mind wander. So even though we've been defining it as the content of thought, what we're thinking about when we mind wander, that will be the same as defining wandering in space as the place where we are currently in space. So I don't know if you're wondering, if you tell me where you are currently, I need to know how you be moving about that space to be able to know if you are wandering or not in that space. And in the same way, we started to think about mind wandering, not as what the thought is about at any one moment of time, but more like as how thought changes over time. In order to, so in the case of Jennifer, thought wasn't changing. She was stuck in whatever mental state she was, stuck enough that she wasn't able to change out of that state into a perceptually tuned state and stop before the car. In the case of something like rumination as well, we're not wandering wildly around our own mental spaces. We're usually ruminating on one thing in repetitive fixed fashions. So rumination and intrusive thought are actually very different from the kind of wandering or the kind of spontaneity that you can have in mental space. So this was an intuition that Zach came in, which was very influential to what I'll tell you about last. And it's this idea of thinking about thought as a two-dimensional space. So Zach and I, along with 3 other colleagues of mine, shown here, published a paper then in 2016, where we tried to redefine how we think about mind wandering in relation to spontaneous thought. And we introduced a two-dimensional framework in that context. So I'll tell you about this two-dimensional framework. So here, how do we think about thought in a two-dimensional space? Well, we introduced this conceptual space of relating different kinds of thought. So believe it or not, for the first time in my career, I tried to organize different kinds of thought, not on a continuum, but in this two-dimensional space. And so this two-dimensional space was defined, it's very broadly. So there's different kinds of two-dimensional spaces you can have, but in order to capture all kinds of different thoughts, you have to define the dimensions very broadly. So the first dimension here is actually the dimension that I had been thinking for a while. As you remember that one line that I showed you when we talked about continuum, I had been trying to arrange different kinds of thought along a dimension that relates to executive functions very strongly, and is what I then, in this two-dimensional framework, I called deliberate constraints on thought. So thought unfolds, right? And it could unfold spontaneously, but in some cases, we deliberately try to make it directed towards a goal, such as in problem solving, goal-directed problem solving. And in these cases, I'll tell you about this in a minute, but in these cases, when we direct it in a very strong way, so we use our executive functions and we exert deliberate constraints on thought, we end up engaging in goal-directed thought. But if we're not deliberately constraining thought very strongly, then we're in that range of that continuum of spontaneous thought. And in this case, I've ordered here mind wandering, creative thinking, and dreaming, actually in a similar way that I showed you before in terms of the one-dimensional thinking of thought. Now, if you're only thinking of it one-dimensionally, then mind wandering and rumination become indistinguishable because they're both not very deliberately constrained. Rumination happens on its own, and intrusive thoughts, they happen on their own. I'm not causing them to happen, right? They're not intentionally caused. So mind wandering, rumination, and intrusive thought actually would all be put in this box here, right? Somewhere along here, because they don't have very much executive part to them. They're not deliberately constrained. But the new thing that we introduced in here is this second dimension, which changes our thinking about thought actually very drastically. So the second dimension is what we ended up calling automatic constraints. So the intuition here is that mind wandering is unconstrained, and so is rumination and intrusive thought, but rumination and intrusive thought are not the same in mind wandering because they are constrained. They're just not constrained in deliberate fashion. They're constrained in this more effortless way, more automatic way. And that is how we could distinguish between rumination and mind wandering. And we could also distinguish between things like dreaming and creative thinking and rumination and obsessive thought. So the idea here is that we have a two-dimensional conceptual space, and the second dimension, the first dimension is really executive functions or deliberate constraints. But the second dimension now is much more mysterious, much less studied, although we have some suggestions for it that I'll tell you about. But it's probably one of the most important dimensions, maybe even more important than the deliberate constraints. So even though we've studied almost exclusively deliberate constraints on thought, it's the automatic constraints that make a difference between whether you're going to be able to stop the car when you're approaching the red light, or whether you're going to be able to not stop the car, you're going to not be able to stop the car and potentially crash into the cars. So it's a big difference, right? It may also make the difference between people who are enjoying their mind wandering and people who hate their mind wandering, because it actually for them is not really wandering. For them, it's a ruminative, intrusive, negative experience. So these are the kinds of distinctions that I've now become really focused on studying and trying to find ways to study, because I believe they're the most important for our existence, really, as well as our everyday life well-being. So just to summarize, deliberate constraints are actually fairly well understood. Of course, we've been studying them for a long time. They are fairly synonymous, in fact, with cognitive control and executive functions. And we understand fairly well, although there's always more to understand and more details that we could learn, that they are related to what are known as the control networks of the brain. So in red here, you see the frontoparietal control network. Neuroscience has moved away from emphasizing the prefrontal cortex, which is very important for deliberate constraints and executive functions, but it doesn't perform that function by itself. It works together with regions throughout the brain known as the control networks part of the brain, or the frontoparietal control network. There's also another control network that's less discussed, but those are only parts of the brain that tend to be involved in these kind of constraints. The other constraint, the other dimension here, automatic constraints, is much less well understood. And at a psychological level, things that can contribute to automatic constraints are mechanisms such as affective salience. So this is emotional things that grab our attention automatically. Right? So I think of something, it's emotional, and then if it's really emotionally engaging, I may have trouble disengaging from it or stopping to think of it. Motivational intensity, so things that we're really motivated to do or think about, may also constrain our thoughts and then make it harder for us to go back to a boring task, for example. But another thing that's very under-researched, but very much probably involved in thinking that's more automatic, are mental habits. So how consecutive mental states can become chunked and sequenced in a similar way that we can learn to play an instrument, for example, through habits, or any motor habits that can be formed are probably likely to be shown in mental versions of these kind of habits as well. So this is what really we need to be studying in order to flesh out more richly that two-dimensional view of thought, although we're still not quite there. And more recently, what we've been trying to do is link a few other phenomena that also alter thoughts, such as psychedelic-induced alterations to thought, and positioning that two-dimensional space, and also create a little more complex way of understanding creativity in that space, because creative thought is not really one position in that conceptual space. Creative thought is probably one of the most dynamic way of approaching, of experiencing our own thought. So creativity is actually the shifting of thought between some very highly goal-directed thought to some very spontaneous and free, sometimes crazy thought generation. And it's the ability to shift between these very different kinds of thoughts in very strong extremes that makes people more creative, and also makes more creative people more susceptible to mental health problems, actually. So this is the kind of thing that we've been working about in terms of this two-dimensional space. I'm approaching the end of my time, so I will skip through some of these more neuroscience-y findings. I can tell you about them if you have specific questions, but what I want to tell you is about how I can give you some examples of what our thinking might change, like what we ended up doing in the process of identifying this second dimension, the automatic constraints, is also thinking about what parts of the brain might be involved in automatic thinking. And the frontoparietal control network here, we proposed, and in fact, I think that's fairly uncontroversial, that it's involved in imposing deliberate constraints on thought. But what we ended up doing was linking automatic constraints to a number of other networks of the brain, including the salience networks, which are involved in implementing emotional salience, as well as the default network, especially a part of the default network called the core part of the default network. But in contrast, the mediotemporal lobe part of the default network, so the mediotemporal lobes that I told you about, are in fact considered a part of the default network. We propose they're actually not exerting automatic influences on thought, but they're what is generating spontaneity and variability of thought. Because something needs to be generating variability. If you can't just, the brain cannot be only involved in constraining thought, right? And in fact, we have some data to show that when people generate spontaneous thoughts spontaneously without their own volition, the mediotemporal lobes are the first to become active, something like 2 seconds prior to their reports of spontaneous thought. I skipped through these data, but I just want to conclude here is that when we have this two-dimensional view of thought, it's very clear that rumination and anxiety are not spontaneous. So there's different ways in which the different networks of the brain can configure themselves. Sometimes the frontoparietal control network constrains other parts of the brain to be less variable, but sometimes the mediotemporal lobe part of the brain influences other parts of the brain, including the frontoparietal control network, to be more variable, right? And sometimes the default network and the salience networks, the core part of the network, constrain the rest of the brain to be less variable in automatic ways, which we may experience as rumination or anxiety. But the idea here is that rumination and anxiety are not spontaneous, even though we don't do them on purpose. And so one thing that this is led to is a more rich perspective on spontaneity. So spontaneity, there is a shallow way of thinking of spontaneity, which basically equates it with a lack of intentional causation. But all the neuroscience that I've been engaged in and that I've seen suggests that that's not a sufficient way of understanding spontaneity, including mental spontaneity, because lack of intentional causation is only one of the things that might make things a little more spontaneous in the mind, but it's not the only way, and it's not the only condition. It's not the same as the brain being spontaneous, right? So the reason why that's true is because rumination and anxiety are not intentionally caused. I don't want to ruminate, or I don't want to be anxious, but I am anyway. So my mind is doing it not by my intention, but they're not spontaneous because they're very fixated. So they're constrained in some way, excessively constrained. And this is one of the new things that we're working with in terms of trying to understand spontaneity in a much more rich way. In the case of depression, trauma, and anxiety, clinical therapy, including clinical counseling and psychotherapy, may in fact primarily aim to reduce these automatic constraints. So the reason why automatic constraints and this second dimension of thought may be in some ways more important than deliberate constraints is that sometimes depressed people are told to just get over it. And essentially what that admonition tells people is to use their deliberate thoughts, their executive functions, to get themselves out of depression. And anyone who's been in depression or through trauma and anxiety will tell you that that's not how it works. So how really it works is that you have to change these automatic constraints on thought that constrain it towards a certain space of that two-dimensional conceptual space. So in the case of therapy, some of the things that are very frequently addressed, in fact, are the automatic emotional reactivity. So these are automatic ways in which emotional salience can constrain thoughts, but also habits of thought. So when our minds engage in automatized sequences of mental states that can become triggered and executed as a unit, right? Instead of individual states, those habits of thoughts can, of course, make us unhappy. They can make us suffer mentally and even potentially crash into a car ahead of us. one of the things that I'll end on is that spontaneous thought is now the term that I use to capture a very wide diversity of phenomena, in fact. And some of them are related, and some of them I told you about, like mind-wandering, task-related thought, stimulus-independent thought. But others I didn't talk about as much, like daydreaming, reverie, musing, contemplation, imagination. So spontaneous thought is really broad, and it can only be understood if we analyze the different components of spontaneity. And one of the things that one of my last slides that I'm really interested in is, but I haven't done so far, is actually doing linguistic analysis across different languages. So I told you about everything I told you about, of course, is in English, and is in fact implicitly informed by how the English language subdivides spontaneous thought and its related phenomena. Most of you here speak Bulgarian. One of the things I briefly did as I was putting together this talk is went to see the different meanings of spontaneous. So in Bulgarian, spontanen, the word has as many as 6 different meanings. Some of them are related to the different meanings of spontaneous in English. But if anything, I actually in Bulgarian, at least in this particular dictionary, I see a richer dimensionality of spontaneity itself. So one of the things I'm interested in is actually doing a linguistic analysis across different languages to see how different dimensions of spontaneity are implicit and potentially differently represented across different languages. Because I think as scientists, we can learn a lot from languages that try to capture these thinking. And in fact, literature is one of the richest sources for me of inspiration when it comes to how to think about thought differently and more richly than what science tends to take us to. So in conclusion, what I've shown you is that there is different ways to think about thought. And the point, thinking about it as a point, is probably oversimplistic, but surprisingly, it continues to this day in science and outside of science. We think about thought as a point whenever we try to see it on a simple continuum, active, passive, productive, unproductive, and then try to force our thought into a point of that continuum, which for whatever reason we believe or we're told, or for some reason we feel that that's how our thought should be. The continuum is a slightly better and more complex way of thinking of it, but it really struggles to capture the complexity of thought, as well as the neural findings that we have about thought. And what I've told you about is these newer attempts that we've engaged in to think about thought in a two-dimensional space, especially try to understand these automatic constraints on thought that are probably the key to mental health, as well as to our well-being, and to understanding how to apply scientific findings to thought. Now you might think, well, the world is three-dimensional, at least. Why just stop at 2 dimensions? And that is true. The reality of it is that actually the reason why I'm temporarily stopping at 2 dimensions is because we're actually really having troubles characterizing automatic constraints at this point at a neural level. And we're still trying to develop paradigms and procedures, experimental procedures to do it. But I do think that at some point, maybe in my lifetime, maybe not, we'll be able to start trying to break down potentially this automatic constraint dimension into maybe a dimension of its own, in which case we might be able to actually see more than 2 dimensions of space. So overall, I want to leave you at that and welcome any questions. I know I've used up all of my time, so I hope some people have time to stay, but if not, I welcome questions over email afterwards. And in conclusion, I want to thank all the people who helped me do this work, and in many cases did the work, including my graduate students and my many collaborators. And thank you all for listening.